1.4 Charge in a uniform electric field. So students should be able to explain quantitatively with the aid of a diagram the motion of a charge in a uniform electric field. Next, use E equal to delta V over D for uniform electric field in stationary charge, charge moving perpendicularly to the field, charge moving parallel to the field, and charge in dynamic equilibrium. Hi, Assalamualaikum and very good afternoon. Today, we want to discuss the last subtopic in this chapter. 1.4 Charge in a uniform electric field. So this charge is moving charge, therefore we can label as Q0. Now refer to a diagram motion of a charge in uniform electric field. So we need to draw the charge when moving in uniform electric field. Okay, the first idea is when the charge or moving charge moving in a uniform electric field, so the shape must be parabolic path. Now, let's say we have two types of moving charge. Maybe we can write as a Q0 for the positive, maybe proton. Another one is negative charge, maybe electron. Now, referring to the upper plate is positive, lower plate negative. Same with the diagram. This diagram, upper plate positive, lower plate is negative. So, from here, the electric field line, when we draw, the electric field line must be from positive to negative. So that's why when we draw by using the arrow must be from positive to negative. So we can write as E. Same with this diagram. Okay, this is uniform electric field. Why we call as a uniform electric field? Because of the spacing here. Equal or same. So when we draw the equal spacing, so means what? Uniform electric field. Okay, let's discuss when the test charge or moving charge entering these two plates. Let's say proton, initially moving with initial velocity. So what happened to the proton? So normally positive charge will be reflected towards negative. So means what? Okay. This is the final velocity when the charge emerge from the plates. What happened to electron or negative charge here? When initially moving with initial velocity, so negative Q naught will be reflected towards positive plates. So by looking at these two shapes, this one and this one, so this is we call as a parabolic path. Now, we want to discuss why. Why the positive Q naught reflected downward, then negative charge reflected upwards. Why? The concept is here. Positive charge will be attract toward negative. Means what? The electric force should be downwards. Am I right? For the negative Q naught here, negative normally attract towards positive plate. So that's why the electric force is upwards. Okay, next. The direction of acceleration will be same with the direction of electric force. Meaning, the direction of acceleration should be same with the force. The direction of acceleration produced should be same with the direction of the force. Next, if we want to calculate this acceleration A, so kalau kita nak kira acceleration A, now by using this concept, force equal to ma related to the Newton second law. Another equation for the electric force, Q naught E. Actually, this equation is come from definition of E. Remember, electric field strength is the electric force per unit positive test charge. Then substitute Fe equal to Q naught E equal to ma. Rearrange so we can calculate the value of acceleration using Q naught electric field strength over mass of the moving charge. Notes. The magnitude, let's say, if the moving charge is electron and proton, the magnitude of the charge must be equal. This is the value. Next, how to determine the value of E here? So, how to determine the value E here? So, by using E equal to delta V over D. V is a potential difference in unit volt. D is a distance between two parallel plates. Meaning, from upper plate to the lower plates. This is D. Same with this diagram. This is D. So distance must be in meter. Therefore, from here we can state unit for the electric field strength volt per meter. Or normally we can use Newton per coulomb. Next, we want to discuss the final velocity here. Okay, let's say this when the proton or positive charge emerge from these two plates, and then this one when the electron, maybe electron or negative charge emerge from the two plates. Now, we want to discuss how to calculate this final velocity. Okay, now referring to this diagram, so we want to calculate the final velocity of the test charge Q0. Okay, let's say this is the upper plate, positive. This is the lower plate, negative, positive, negative. So, step 1, we can draw the electric field lines. Must be from positive to negative. So, maybe we can label SE. Now, let's say this proton. Let's say this charge is proton. Okay, so initially moving with initial velocity u. So what happened to this proton? What happened? So this positive charge will be reflected downward. Am I right? Yes. Okay, look at this. I want to all of you focus at this part. Incline vector. Incline vector. So we need to find Vy and Vx. So when the positive charge reflected downwards, meaning the electric force produced should be downward. Same with the acceleration is going downwards. Now, we can categorize the value in terms of X component and Y component. Okay, now we want to discuss initially acceleration at x0. Why 0? Okay, look at this acceleration actually directed downwards, meaning at y axis. And then ux equal to u because of initially the charge moving at x axis. But uy equal to 0. Next, when we want to calculate Vx should be equal to Ux. Then when we want to calculate Vy, so we can use U plus AT. Next, the range or horizontal displacement as x. So where your sx? Okay, referring to this diagram. So this is your horizontal displacement. When we want to calculate vertical displacement, we can use sy equal to uyt plus half at square. So where your sy? From starting to the plates. So this is sy. Okay. Then how to calculate magnitude? So this is the equation. And then we need to determine the direction. Last for today, I want to show you this mesh here. Okay, look at this. M, so symbol M refer to the mass of moving charge. Just be alert. Elementary charge E. So just jot down the value of charge electron and proton equal. This is the value. But refer to the mass. Mass proton we use in kg. Mass electron we choose in kg. Okay, bye.